Today we're just going to do a couple more examples of taking complex numbers and changing them between polar and rectangular form. And for these examples, we're going to need a calculator because they're not problems that you can do using 30, 60, 90s or 45, 45, 90s. There are two problems in the homework where you'll need the calculator, and those are noted here. For this one, we want to convert from rectangular to polar, and the complex number is 7 minus 2i. So my x is 7, the real part, and my y is negative 2, the imaginary part. My x is 7, so I go across 7. My y is negative 2, so I go down 2. 7 and negative 2 are not in the ratio that we need for the special right triangles. So in order to solve this problem, we're going to need to use Pythagorean theorem to get the radius. And when we do that, we get r squared equals 4 plus 49 is 53. So the radius is square root of 53. And then to get the angle, we need to find the angle going around this way. But the first thing we can solve for is the angle inside of this triangle. So if I call the angle inside of the triangle theta, we know that tangent of theta would equal opposite over adjacent negative 2/7. When you put that in your calculator, and you can do these in degree mode to make it easier, when you do it in your calculator, you're going to take the inverse tangent of negative 2/7, and it gives you negative 15.95. So this is going down 15.95. The angle we want goes all the way around. So what we need to do to put into the equation is take 360 minus the 15.95, and that will give me an angle of 344.05 degrees. So when we write our polar or complex numbers in polar form, we put r and then cosine theta plus I sine theta. If you wanted to check this at all, you could multiply square root of 53 times cosine 344.05 to get, you should get 7, and then square root of 53 times sine 344.05, and you should get negative 2. So again, number 22 in the homework, you'll need a calculator. Go ahead and do it in degree mode. This one, we're going to convert from polar to rectangular form, and we have the angles in radian mode. So you need to put your calculator in the correct mode. Put it into radian mode because the angle's in radians. Now, if I distribute this 4, this says that z is 4 cosine 3 pi over 7 plus I times 4 sine 3 pi over 7. This 4 cosine 3 pi over 7 is x. As long as I'm in the correct mode, I'm going to put all this in my calculator to get the x value, which is 0.89. And then I'm going to put 4 sine 3 pi over 7 in my calculator to get the y, which is 3.9, and the I. And you don't have to worry about any positives or negatives here. It will come out correctly from whatever you put in your calculator. We're not going to do much more of section 9.3. So today you're going to do more practice with what you did yesterday and these couple calculator problems. The reasons for putting these complex numbers in polar form and graphing them have to do with taking roots or raising complex numbers to powers. There's something called De Moivre's theorem. It's in the book, but it's something that you might see down the road if you were taking calculus.